Hello, my name is Jumel Ziu. Today we'll be building and evaluating unsupervised learning models in data science, looking at the PCA, the K-means, and hierarchical clustering. So the project overview, basically under unsupervised, we're going to apply the technique to cluster wine data with our label outputs. The pattern discovery, which aims to discover hidden structure within the raw input data. And then we're gonna get the data-driven insight by extracting meaningful pattern using advanced clustering method. So during the project, what was done, so we basically prepared the data by standardizing the features to prepare the clustering analysis. And we use the PCA for dimensionality reduction. So basically reduce 13 features to like 5 components, which preserve 80% of the information, the variance. And once that was done, so then we proceed with the clustering implementation, where we apply like the K-means and hierarchical clustering with optimal k equals 3. And then we were able to visualize our outcome by plotting the final cluster in PCA, reduce space for analysis. So why is it important, or why does it matter in industry? Well, in retail you can, because we discover a customer segment for targeted like marketing. And in healthcare, we group patients by similar condition or outcomes. And for finance, you can see we can detect anomalies in transaction patterns. And then in the manufacturing realm, we improve the strategic, planning through data grouping. So basically, the key takeaway from here was basically, simplify the data sets through PCA, which, dimensionality reduction without significant information loss. And we validated the clusters by using the silhouette score, which was obtained, and then we got like 0.37 confirmed with good clustering separation. And we reveal the structure through the models and uncovered pattern in raw and unlabeled data. And then the foundational pipeline, which established the framework for data exploration and pre-processing. So how was that done? So we actually implemented like the elbow method for optimal K. So the insight that we got from there, so it was like the initial decrease as the cluster count increases. So the curve show a clear elbow at K equals 3. And after that point, so if we adding more cluster, that will just, lead to decrease, diminishing like the return. So it will not change anything. Everything will just decrease. Why that matters? Because it helps us identify, the optimal number of cluster. It prevents the overfitting with too many clusters, and it is essential in unsupervised learning without guiding labels. And on the silhouette score evaluation, as I mentioned, we got 0.37, which was the peak score, which indicate a well-separated and cohesive cluster. And then we have a +1, which was the maximum possible outcome, and it means that the perfect cluster separation theoretically. And for the minimum, it's like -1, compared to the overlap, which was a poor indication in this case. So but the threshold, we got like 0.25 minimum for, meaningful real world application. So here, that was actually the result that we obtained. As you can see on the left hand corner, we had the elbow method, and you can see like the elbow on number k equals 3, it starts to decline, as I mentioned earlier. On the silhouettes, a score, we got like a 0.37. And then on the PCA, so we could observe how the curve was actually uh, described here on the image. And then the PCA here, after running that into Python, so you could see on the left right hand corner we had the score of the 0.37, and then he basically help us reduce like the 13 component to like 5 principal component, which capture like 80% of the variance. So adding more of components will not contribute too much of on the analysis of the data set. So, and we also run like the clustering dendrogram, which help us visualize the netlist structure in the data to get like a strategic coding, which forms basically 3 distinct color coded cluster. And then each branch reflects dissimilarity between the groups. So the dendrogram confirmed that the k equals 3 findings from other method while providing visual evidence of data group. And then here is the picture of the different group that were made, so you can see clearly that we have like orange group, green group, and then the red group. So even within those groups we still had like couple groups mentioned that. So that actually clearly uh, tell you that the grouping took effect. And then that concludes basically our presentation of today. And then this is the reference that help us actually get to uh, finalize our analysis. And it provides like a theoretical foundation for the approach used in this project. And then we can connect by sharing our insights, learn together and build more connection. And thank you very much for the time watching this presentation.